Hello, and welcome to 5 Minute Math. Today we are looking at the fifth grade concept of solving data problems. This is 5.9c Readiness Practice, the Proficient version. If you're interested in exploring the 5.9c Readiness Practice for either the intermediate or advanced versions, or the Readiness Practice resource line with any other standard, you can find those by using the link in the video description. So we have a dot plot here showing the number of kilometers students ran in a week. And our first question is, how many students ran this week? Well, what we're going to do is we're just going to count how many dots we have. Each dot represents a student running. So that's one of the easiest questions we can get here. And so let's see. I'm going to go ahead and put some numbers up on top of these bars. So if I have to count any more, I don't have to do it multiple times. So that's 2, that's 4, that's 6. Notice how it's kind of lined up like a bar graph, and each row is exactly equal. Makes it very easy to count. And you've got this one random kid over here that ran a whole bunch. So 2, 4, 6 is going to be 12, 15, 16. So there's 16 students. How many students ran more than 2 kilometers? All right, so here's my 2 kilometers. I'm not counting that. I need anything on this side of that. So I need to be what's greater than 2. It's going to equal, so my 6, my 3, and my 1, that's 10. Now, what fraction of the students ran a distance represented by a whole number? Okay, this is where we get into the fact that I've got these first two kids ran between 1 and a 2. So we're going to call that a 1.5. We're going to call this a 2.5. And then this one random kid ran 5.5. We call this an outlier because this piece of data, actually called a datum, that for an individual data set, is just out on its own. And there's not really anyone with this one. And so sometimes you'll see data and you'll see an outlier because all the data is kind of grouped together. And then there's one point that's just out by itself. But we're looking at the fraction of students that ran a distance represented by a whole number. So I've got my 2. I've got 4 kids that ran 2 and 3 kids that ran 3. And those are my only two whole numbers. My 1.5, 2.5, 5.5 I can't use. So it's 7 out of how many total kids? We already answered that. 16. So 7/16. And then the difference between the least amount, remember this is called the range. Just the difference between the greatest and the least. My greatest is 5.5. My least is 1.5. Now you'll see 6 and 0 and 1 on the graph. We're not counting those. We're only counting the greatest and the least numbers that have a dot above them. And that's just going to get us 4. So that's my range is 4. All right, so now we've got Mina with a dot, with a scatter plot here. Mina scored for 8 spelling tests. All right, on what fraction of the spelling test did Mina fail? Okay, so let's figure out what that means. Fail is going to be less than 70. So 70 works, but if you're less than 70, so let's get a straight line here. And let's just draw a line across that 70 so we can visually see. All right, so there's my 70. Now, that one that's right on the 70, we're going to count that as a pass. So let's just count the fail as this one and this one. Okay, so on what fraction? So it's going to be 2 out of, well, we already said 8. There's 8 total spelling tests. So 2 out of 8. Now, we can simplify that by dividing the numerator and denominator by 2. And we're going to get 1/4. All right, so you can say 2/8 or 1/4 of Mina's spelling tests he failed. Now, if Mina studied for 4 hours for ninth test, what do you think his score would be and why? Okay, so you notice how the more Mina studies, the better he tends to do, right? And so we almost see an upward trend. And so I'm going to draw a green line here. We call this a line of best fit or a trend line. What we're trying to do is we're trying to kind of draw a line in between some of these data points. It looks like Something along that line. That's kind of my best estimate. I try to make it land in between the numbers on 2, the numbers on 3, and the numbers on 5. And it's not going to be perfect, but if I were going to do 4, my best guess is that using this estimated line of best fit, it's going to be either an 80 or an 85. I'm just going to kind of land right there, right? Those are the two, at least, lines to land between. So if I wanted to get technical, I might call it maybe an 83. Um, so I might say, I think he would score an 83. And then why? Well, because that lands, or that fits, remember, we call this a trend line. It's just an estimate. That fits my trend line, but that anywhere between that 80 and 85 is probably going to work. For our third problem, we have a stem and leaf plot, and we've got our key that we always need to keep track of. So the 1 and then the line and the 5 means 15, so this is my tens place, this is my ones place. So how many students recorded the reading? Well, what we do is we count how many leaves there are. We don't count the stems because the 0 and the 10 just help build the number. The leaves actually record the students. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to stop there because, like a dot plot, each number in the leaf is lined up exactly evenly with the one above it or below it. So if I've got 12, right, then I could just double that and then add 1 for my second one. Let's just verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there we go. I've got 12 and 12, and then one more that makes 25. So that's kind of a trick. When you're adding really long leaf plots, you can just count one row and then know that that's the same number that's going to be on the row above or the row below. The difference between the greatest and the least number, remember this is called our range. So what is my greatest number? Well, it's a 1 and a 9. So that's going to be a 19 minus a 0 and a 1. So you have to do the first number in the leaf row on the first row, but on the second row, you do the final number. So 19 minus 0, 1, really, we're just going to call that 1. So my range is going to equal 18. And then which fraction of the students read an even number of pages? Well, it's going to be over 25. Remember, there's 25 total students. Let's count the even numbers. So 1, 2, 3, 4, 5. And then we're going to count that as 6, 7, 8, 9, 10, 11, 12. All right, so 12 out of 25 students read an even number of pages. Those are the numbers that end with digits 0, 2, 4, 6, or 8. If you're interested in exploring the 5.9C Readiness Practice resource aligned with the intermediate or advanced version, or the Readiness Practice resource aligned with any other standard, you can find those by using the link in the video description.